Alrighty guys, this is the Unit 1 review, so if you are here, make sure that you have given that study guide your best go, and then check your answers here and your work. So, starting off, identify if each relation is a function, and if it is a function, identify if it is a one-to-one function. Okay, so remember functions are like people and birthdays, right? People are the x's or the inputs, and then birthdays are those outputs or those y values, okay? It is possible for two people to have the same birthday, right? But one person cannot have two birthdays. So starting off with number 1, it looks like 0's got a birthday of -2 and a birthday of 1. So is that possible? No, that is not. So this is not a function, therefore it cannot be a one-to-one function either. And remember those one-to-one functions were like if everybody in the room had a different birthday. Okay, so no x's repeat, no y's repeat either. Looking at number 2, is this one a function? Yes, it is a function, right? No x's repeat. Is it a one-to-one function though? No, because 4 and 11 both have an output of 5, or a birthday of 5. So that's going to be a no, it's not a one-to-one function. Okay, number 3, same thing. Looks like no x's repeat, so this one is a function. Do any y's repeat? No, it doesn't look like it. So this one is both, okay? Number 4, looks like 1's got 2 birthdays, so no on that one. We'll go on down. Number 5, okay? These graphs, the easy way to tell if this was a function is, does it pass that vertical line test? Does it only hit a vertical line one time if I draw a vertical line through it? So it looks like this one only hits once, no matter where I draw it, so it is a function. But is this a one-to-one function? Okay, make sure you really look at these. Are any of my outputs repeating? So if I look, when x is 0 and when x is 2, they both have an output of 1. So they both have the same output, so that cannot be a one-to-one function. Number 6, though, does pass the vertical line test, and it doesn't look like any of these have the same output, okay? So this would be yes on both. All right, moving along to our compound functions. Okay, so the first one, number 7, f minus h of x. Okay, so remember that if we were adding, subtracting, multiplying, or dividing, we could easily just split it into 2. So this would just be f of x minus h of x, okay? So first thing, I just want to go find f of x. It is 2x squared minus 3x plus 7. Okay, and then I'm subtracting all of h of x, which means I need to put h of x in parentheses, because I'm not just subtracting this first number, right? I'm subtracting the whole thing. So I've got to use parentheses to show that I'm subtracting the whole entire h of x. So when I go and I simplify this, it just becomes 2x squared minus 3x plus 7 minus x cubed, and then plus x squared. Now I just want to combine like terms and write in descending order. So I just have negative x cubed as my only x cubed term. 2x squared plus 1x squared is 3x squared. And then negative 3x plus 7, don't have anything either. And that's my answer. So we're just simplifying the expression there. Next one, similar, right? But this is multiplication. Don't get this confused with g of h of x. This is a closed dot, which just means multiplication. So anytime I'm multiplying two functions together, I'm multiplying the whole thing, so I need parentheses around both. And when I work this out, I get 7x to the 4th. Again, when you multiply two things together, you multiply the coefficients, add the exponents. So this is the same as x to the 1st plus x to the 4th would just be x to the 3rd would be x to the 4th. Okay? And then 7x times negative x squared is negative 7x cubed, negative 4x cubed, positive 4x squared. Combine like terms. 7x to the 4th minus 11x cubed plus 4x squared. That's my answer. Okay, continuing on with compound functions. We're almost done on these. Number 9, pay attention to that dot. Is it a closed dot or an open dot? it is open, right? So this is the same thing as f of h of x. Okay, so I need to plug in h of x everywhere where there is an x in f. Okay, so how I'm going to do that is I'm going to keep everything of f, but everywhere that there's an x, I'm just plugging in x cubed minus x squared. Now I just want to simplify this as much as I can. First off, this first parenthesis is being squared, okay? So I have to do that before I can distribute out that 2. Okay, if I distribute out that 2 first, it's going to give me a completely different answer. Foiling always comes first. So this is the same thing as 2 times x cubed minus x squared, x cubed minus x squared, because again, this whole parenthesis is being squared. Anytime I square something, I'm multiplying it by itself, okay? So x third minus x squared, multiplying it by itself, okay? So that's why I'm writing it out twice. I can go ahead and distribute to simplify this next part. Okay, so now the only thing I've got to do is FOIL this out and distribute the 2. So that's what I'm going to do. So x to the cubed, or sorry, x to the third minus, not minus, times x to the third is x to the 6th. X to the third times negative x squared is negative x to the 5th. Same thing here, negative x to the 5th and positive x to the 4th. Okay, I just simplified this whole thing, but again, remember it's still being multiplied by 2, so don't get rid of that 2 yet. We haven't done anything with it yet, but we're about to. We can distribute it to everything in the parentheses. So 2x to the 6th minus 2x to the 5th minus 2x to the 5th. I could have combined those 2x to the 5th first, but I didn't, and that's okay. Because now I'm just going to combine all of my like terms. So when I do that, I've got 1x to the 6th, so that's just 2x to the 6th, or one term with x to the 6th is 2x to the 6th. We've got 2 terms with x to the 5th, so that becomes negative 4x to the 5th, plus 2x to the 4th, minus 3x cubed, plus 3x squared, plus 7. And that is it for that one. Next one, let's hope it's a little bit shorter than that. There's a lot of work. There's a lot of work to be shown. Okay, g of h of x. It's going to work the exact same way, okay, but we're plugging in h of x into g. So if we look here, g is 7x minus 4, so I'm just going to plug in x cubed minus x squared into that. That one works out pretty easy. 7x cubed minus 7x squared minus 4, and that's it. That's all I can do on that one. Okay, number 11. All right, be careful with number 11. This one was put in there to trick you. I'm going to go ahead and erase all of this so I have a little bit of room. This was put in there to trick you. What is the operation here? It's a closed dot. That means multiplication, okay? And we're not doing multiplication of f of x times h of x, but f of 3 times h of 3. So this is the same thing as f of 3 times h of 3. So I just need to find f of 3 and h of 3 and then multiply them together, okay? So I'm going to do that. If I plug in 3 into f, it's just 2 times 3 squared minus 3 times 3 plus 7, okay? So if I plug that into my calculator, 3 squared is just 9 times 2 is 18, minus 9 is 9, plus 7 is 16. And then h of 3 is just 3 to the cubed minus 3 squared, which is just going to give me 27 minus 9, which is 18, and 16 times 18 gives me 288 is my final answer. Because again, 16 times 18 is how I did that. Okay, moving right along, g of h of negative 2. Okay, so this one is a composite function, so I just need to find h of negative 2 and plug that into g. okay? H of negative 2 is just negative 2 cubed minus negative 2 squared. Put that into your calculator. Negative 2 parenthesis to the third power minus parenthesis negative 2 squared, and you should get negative 12. So now I just need g of negative 12, which is just 7 times negative 12 minus 4, which gives me negative 88, which is the same answer that should be on that review guide. Okay, moving right along. Evaluate using the function. Here's a piecewise function. We don't even have to graph it yet, okay? We're just evaluating. Just evaluating on this one. So, what it wants us to do is just to plug in each of these numbers. So first is f of negative 3. Okay, well, which piece do I need to plug it into? I don't need to plug it into all of them. I just need to see when x is negative 3, what piece does it go in? So would that be less than or equal to negative 4, between negative 4 and 1, or greater than 1? Hopefully you know that negative 3 is between negative 4 and 1. Okay, so negative x minus 1 or negative 3 minus 1 gives me 3 minus 1, which is 2. 14, we have a 1. Well, this isn't x is less than or equal to 1 or x is greater than or equal to 1, so 1 actually isn't even defined here. So anytime that there's just an open dot on both, it's just going to be what we call undefined. Negative 4, well, this is x is less than or equal to negative 4, so that can go there. So negative 2 plus 3 is just going to give me 1. And then f of 4, obviously that's greater than 1, so plug that in. Use a calculator. There's no reason that you need to do that in your head, okay? And you should get 35. Next up, we've just got functions, okay? These go back to pre-algebra. They're not too bad, okay? Addison painted her room. Don't get scared because it's a word problem. Addison painted her room. She had 50 square meters to paint, and she painted at a constant rate. Constant rate. That means this is going to be a straight, constant line, right? After 2 hours, she had 35 square meters left to paint. Write a function to model this scenario. Okay, let's think about that. So what do we know? We know that she had 50 square meters to paint. After 2 hours, she had 35 left to paint. Okay? So at 0, she had 50 left to paint. After 2 hours, she had 35 left to paint. So I can make a line out of this, correct? If I have 2 points, right? So y2 minus y1 over x2 minus x1, that's how we find what the slope is, okay? And then we just plug it back in to get our equation. This was something that we learned how to do in pre-algebra, also in algebra 1, so a little flashback here. y2 minus y1 is going to be 35 minus 50, x2 minus x1, 2 minus 0. 35 minus 50 is just negative 15 over 2, which is negative 7.5. Now I can just plug in either one of these points. I'm going to pick the first one just because it has a 0 in it, and I think that's easier. Plug it into y equals mx plus b so that we can find b. Okay, because we have m. M is negative 7.5. Okay, so y is 50. M is negative 7.5 times 0 plus b, because I don't know what b is. This just becomes 0. 0 plus b equals 50. Well, that's just b equals 50, right? Okay, so I have b and I have m, so now I can write a function to model this. So it is the same thing as y equals negative 7.5 x plus b, which is 50. Since they said function, I could go ahead and just put f of x instead of y, because I know that that's the proper way to write function notation, but I know it means the exact same thing, and I'm not going to count it wrong if you give me a y. 7. Okay. How much painting will be left after 3 hours? What is f of 3? Pretty simple to just plug that in to my equation, right? So negative 7.5 times 3 plus 50 gives me 27.5 square meters, right? And then when will she be finished? Okay, so think about that. When will she be finished? How will I know when she's finished? So, if she's finished, won't that mean that she has 0 square meters left to paint? Right? That was a little tricky. If you try to plug in 50, you'll end up just canceling yourself out and getting 0, okay? But 0 hours left to paint, so that's what y is, right? Is how many hours we have, or what we have left here, or how many square meters we have left. Subtract 50 over. So I end up with negative 50 equals negative 7.5. X divided by negative 7.5. So negative 50 divided by negative 7.5 is 6.6 repeating. So we'll just put that 6.6 repeating hours. Okay. Soccer team is ordering t-shirts. Shirts cost $8. It will cost a total of $13 to have them shipped. That one's a lot easier than the last one. Okay. So $8 each, it will cost $13 to have them shipped. Y equals 8x plus the shipping cost, which is 13. Or f of x equals 8x plus 13. How much will 31 t-shirts cost? Easy, just plug in f of 31. It's going to be 8 times 31 shirts plus the shipping cost. 8 times 31 plus 13 in my calculator gives me $261. Great. And if they only have $350, so that's why, right? We're not solving for the amount of money, but if we know the amount of money, set that equal to my equation and solve for shirts, which was x. So subtract 13, 350 minus 13 is going to give me 337 equals 8x. Divide by 8, divide by 8. Gives me 42.125. Okay, so can I have 0.125 of a shirt? No, but I can have 42 shirts. So that's going to be the answer that I'm looking for. Okay, cool, let's keep going. All right. We've got graphing composite functions. Okay, these ones we talked about in class, okay? It's just plugging in that composite function and then graphing it. So 2 times f of x is going to be 2 times 4x plus 2 plus g of x, which is negative 3x minus 8. So 8x plus 4 minus 3x minus 8 gives me y equals 5x minus 4. So my b value is negative 4, and my slope is 5. Same thing over here. I've got a composite function f of h of x minus 21. So I'm going to plug in h of x into f. So 4 times negative 1/3 x plus 6 plus 2 minus 21. So negative 4/3 x plus 24 plus 2 minus 21. 24 plus 2 minus 21 is just 5. So negative 4/3 x plus 5. 5 is the b value. Negative 4/3 is the slope. H plus j of x is going to give me h of x, which is negative 1/3 x plus 6, plus j of x, which is 3/4 x minus 2. Okay, we're adding these things together. So negative 1/3 plus 3/4. I'm literally just going to type that in a calculator. Negative 1/3 plus 3/4. Use that ABC button. Gives me 5/12 x. And then 6 minus 2 is just 4. So my slope is 5/12. It looks like that's not even going to be on this graph. It would be way up here, but it would be a line to look like that. And then we've got g of j of x. I like to write it like that. Okay, so in my g function, I'm plugging in j. So this gives me -9/4 x plus 6 minus 8, which is just y equals -9/4 x minus 2. Okay, go ahead and graph that. So go down -2, and then I'm dropping down 9, going right 4, or the opposite of that is going up 9 and left 4, which is going to look like this. All right, next up we've got inverses. So these are where we graph both functions, okay? First thing we do, write out the function and graph it. So f of x is x plus 2. Graph that. 2 with a slope of 1. Okay, that's not beautiful, but that's okay. Then we change it to a y, swap x and y. Whoops. There we go. Solve for y. So subtract 2, x minus 2 equals y. And now that's f inverse of x equals x minus 2. So go ahead and graph it. Still got a +1 slope. Looks just like that. Okay. Moving right along. We'll just move that. Okay, so g of x, same thing. G of x is -3x minus 8, which is going to be this line right here. Change it to a y, swap x and y, solve for y. Can divide, so this just becomes y equals -1/3 x minus 8/3, because we divided by a -3. Okay. And to graph that, -8/3 is just going to be like a negative almost 3. So like right about here. And then drop down 1, go right 3, down 1, right 3. So it's going to be kind of a, ooh, that was bad. There we go. Like that. Okay. Next up, we've got our h inverse of x. So let's erase all this. H of x gives me -1/3 x plus 2. Swap it for a y. Swap x and y. Subtract that 2. Multiply by a -3 here. That's how I'm going to get rid of that -1/3. You could also divide by -1/3, but if you're not good at dividing fractions, don't do that. So this just becomes -3x plus 6 equals y. Okay, so that is basically just the same thing as h inverse of x is -3x plus 6. Okay, so we need to graph both of them. The first one was -1/3. It looked like this. The next one was slope of -3, and it looked like this. And then we've got j inverse of x, last one here that we're going to do. Okay, so j of x was 3/4 x plus minus 2. So graph that, up 3/4. Change it to a y. Swap x. Okay, swap your x and y. add the 2 over, and then I'm going to multiply by 4/3 on both sides. So that's the reciprocal, that's going to get rid of that 3/4. And when I do that, I get y equals 4/3 x plus 8/3, which is the same thing as just j inverse of x equals 4/3 x plus 8/3. Which again, 8/3 was like a little bit close, or pretty close to 3. And then up 4 over 3. I did that wrong, hold on. Up 4 over 3, there we go. Okay, and it looks like that. And that's it for those inverses. So let's get down to the inequalities now. So this is an and function, I know that because it's written together. Split it into 2 problems. The first problem is 2m plus 1 is less than 9 minus 6m. This whole thing, okay. The next problem is the whole middle and that right side. And now I just want to solve them. So get the smaller variable over to this side, gives me 8m plus 1 is less than 9. 8m is less than 8 when I subtract that 1 over, which m is less than 1 when I divide 8. And then add the 6m for this one. That's going to give me 13m. Subtract the 9. So that's going to give me 13m is greater than 0, or just m is greater than 0, because 0 divided by 13 is just 0. Okay? So this is the same thing as m is less than 0 and less than 1. So if I write it like that, and then I can graph that by just putting it on a number line. Open dots, and I know it's a segment because it was an and function. Okay, we'll go ahead and do the next one. Try to erase all that. This one's an or. It tells me that literally in the problem, or. So we'll go ahead and just solve each side. Move the smaller variable over. So 6r plus 8 is greater than 2. Subtract the 8 over. 6r is greater than negative 6. R is greater than negative 1. And subtract 6r. R, add 7. R is less than or equal to a negative 2. Okay, so I have these 2 answers, and I just need to put them on a number line. So negative 2 is smaller than negative 1. Open dot on negative 1, close dot on negative 2. It's greater than negative 1. It's less than negative 2. So those arrows are going in opposite directions. All right, these next ones are those absolute value inequalities. We know the first step on these always is to isolate. Isolate first. Do not split these apart until you've isolated them. You're going to get the wrong answer every time. Okay? So, first thing I want to do then is I want to pretend that this was a variable. Obviously, I have to flip it back, but if I had 2n minus 1 is less than or equal to 33, how would I solve that? I would add the 1 first, right? And then I would divide by 2. I'm doing those exact same steps on this. I'm adding the 1 first and then dividing by 2 to isolate. So this becomes a 34 with this. Divide by 2, 34 divided by 2 is just 17. So now I have my absolute value is 3 minus 5n is less than or equal to 17. Okay, I'm going to erase this just so I have more room. Now I'm ready to split this into 2 problems. The first one, drop the bars, keep everything the same. The next one, drop the bars, flip the sign, make the right side negative. And now just solve like normal. When I divide by a negative, I have to flip my inequality, so this just becomes n is greater than or equal to negative 14/5. And then subtract 3, this is negative 20. again, I'm dividing by a negative, so I'm flipping that sign. N is less than or equal to 4. So, to write this, n is greater than or equal to negative 14/5, and it's less than 4. So to write that as a phrase, it'd look like that. And to graph it, it would look like negative 14/5 is obviously going to be first. 4 is going to be next. They're going to be both closed dots. And it is a line segment. And again, when I isolated it, I knew this was a less than sign, so I knew it was going to be an and. Okay? So make sure you know that. All right, number 30. Subtract 1, and then divide by negative 9. When I do that, this is going to flip. Hold on. To be negative 1, because again, 10 minus 1 is 9, divided by negative 1, 9 is negative 1. Can any absolute value, can a positive value, because again, we know absolute values are always positive, can a positive value ever be less than a negative number? No. So I can go ahead and spot from the start that this one's going to be no solution. Anytime you get an absolute value that is less than or greater than a negative number, it's going to be one of those special cases. So if we hop on down to number 31, we'll go ahead and we'll isolate that one. So we'll subtract the 7. We'll end up with 91 on this side. Divide by negative 7. We know that flips our sign. So we have our absolute value is greater than negative 91/7. Is that possible? Can a positive number be greater than a negative number? Duh, right? So that's going to be all real numbers. That's how we spot those special cases early. Okay. The next one, number 32, subtract the 7, right? 63 minus 7 is 56. Divide that by 2. 28. So our absolute value of 9n plus 1 is greater than 28. Okay, that's not going to be a special case because that 28 is positive. But I can go ahead and split. It's a greater than sign, which means this should look like an or. 9n plus 1 is greater than 28, and 9n plus 1 is less than a negative 28. So go ahead and solve. This one gives me 9n is greater than 27, or n is greater than 3. And then 9n is less than negative 29. So n is less than negative 29/9. We'll figure out what decimal that is. We don't actually have to figure it out because we know on a graph that that's going to be first because it's negative 29/9. 3. Open dot on both. It's less than 29/9, greater than 3. That's it on that one. Now we're up to transformations. So describe the transformation from f of x to g of x, which we notice on both of these that f of x is that parent function for either absolute value or quadratic. The first one, we know that exponent tells us that is the parent function for a quadratic. Okay, so what happened here? How did we get from f to g? So let's just read this from left to right. So the 5/3 here, so it's positive, so that tells us we didn't reflect, okay? But is 5/3, that number, is that bigger or smaller than 1? Greater than or less than 1? It is bigger than 1. So is that telling us to stretch or to compress? Okay? It is compress. If the number is bigger, it is compression. So compress by a unit of 5/3. And then the only other thing is this -2, which tells us to just shift down 2. Okay, the next one, it's got the absolute value bars. That tells me that's the parent function of just absolute value of x. How did I get down here to g? So we'll start just left to right. So the negative sign, that tells me to reflect over my x-axis. That's the first thing. Okay, then we've got this 3/5 here. Okay, so just looking at the number, okay, so 3/5, is that less than 1 or greater than 1? less than 1, right? So that's telling us to stretch or to expand by a unit of 3/5. And now it's not going to be by negative 3/5 because we already took care of that negative. We said that that reflected us, okay? So just a unit of 3/5. And then this 7 is inside the absolute value, so that's the h, okay? So that is telling me to actually go left 7, because if we think h is always the opposite, right? So if it says that it's positive, it's actually negative, which is going to tell me to go left, okay? Moving right along. Heading on down to the graphing function, or graphing section. This is graphing functions. Definitely pay attention to each of these and how we do this. Okay, so the first thing, no matter what you're graphing, make sure that you find the vertex first. So we look, what kind of function is this? Well, we see that we have these absolute value bars, right? That tells me this is an absolute value function. So my vertex is going to be opposite of h, so negative 3 is a positive 3, and my k is 1. 3, 1. Domain is always going to be negative infinity to infinity on these. Okay, we know that these is an absolute value. Think absolute value. It's got that big V, right? Just like this. When you think absolute value, think V. So I know this is going to be a V, and I know that whether it's an upside down V or a right side up, it's going to have a domain going from left to right, negative infinity to infinity. Okay, range works a little bit different, but first off, before I can find the range, I need to find more points on this. So we can make an XYT chart on absolute values, but it's also just easier to look at A, and A is 2. Well, 2 is actually just going to be the slope, which is 2 over 1. So up 2 over 1, up 2 over 1. That gives me half of my V. And I know that it's going up, so I'm going to go ahead and just reflect up, up 2 over 1, and it gives me the other half of this V. Now I can look and see the range, okay? So reading from bottom to top, because again, that's how we read from range. We read from negative values to positive values, just like we do for domain, negative to positive. So starting at positive 1, right? That's where I'm hitting that y-axis. If I make a line, an imaginary line right there. And going up forever, so up to infinity. So that is how you do an absolute value. We'll go ahead and do number 38 as well. The vertex on this one, again, it's absolute value because of the bars. The vertex, if I don't have anything written in there for h, it's just 0, and k is negative 2. So plot that. My slope on this one, or my a value, is negative 1/2, so down 1 over 2, down 1 over 2, down 1 over 2. It looks like this. Reflect that, down 1, left 2, down 1, left 2. And that's how I graph that. Domain I know is negative infinity to infinity. Range, so bottom up, starting from negative infinity, so those arrows are going down forever, ending at negative 2. Moving right along. Next up, we have what are called, are these absolute values? No, they are quadratics, right? If I have these parentheses here, and I have this exponent of 2, that is telling me that this is going to be a quadratic. So these are not going to be straight lines, right? They're going to be U's. They're not going to be V's, they're going to be U's. Think about the word quadratic, how the second letter is U, okay? That can help give you a little hint there. So let's go ahead and find the vertex. Works just like absolute values. So the opposite of h is going to be a positive 1. K is negative 4. So 1, negative 4 is right here. Okay. Domain I know is going to be negative infinity to infinity. I can go ahead and put that there. I then need to make an XYT chart because again, U's don't have straight lines. We can't use slope on these, okay? But we can find other points. We'll use the vertex as our middle point. 2 points to the left of 1 are going to be 0 and negative 1. Okay, 2 points to the right of 1 are going to be 2 and 3. Okay, now I can just go and plug these numbers in. So I'm going to type this straight into my calculator. So I'm typing 2 parenthesis -1 minus 1 close parenthesis squared minus 4, and I get 4. And when I go plug in 0, I get -2, and when I plug in 2, I get -2, and when I plug in 3, I get 4, okay? So go and plot these points, -1, 4, 0, -2, 2, -2, 3, 4. Make it look like a U, not a V. And what's my range going to be, bottom to top? Looks like I'm starting at -4, and I'm going up to infinity. Okay, we'll go ahead and try the next one now. The same thing. This one's also a quadratic. Vertex, opposite of h is -2, k is 3. Domain, -infinity to infinity because it's a quadratic. X, Y, T chart, two things to the left of -2 and to the right. So two numbers to the left are -3 and -4. Two numbers to the right, -1 and 0. Go ahead and plug these numbers into the equation with a calculator. Negative sign, parenthesis, -4 plus 2, close parenthesis, squared, plus 3 gives me -1. Now if I put in -3, gives me 2. -1 is going to give me 2, and 0 is going to give me -1. Plot these points, -4, -1, -3, 2, well, -1, 2, 0, -1. Got an upside down U, just like that. Range looks like I'm starting at, no, not starting at, I'm starting at -infinity, right, because those arrows are going down forever, and I'm ending at 3. Next up, we've got a piecewise function. Looks like 3 pieces here, okay? So how we do this, we split these into their given pieces. So the first one is just y equals -5. Second piece is y equals 4 minus x squared. Third piece is y equals x plus 1. Y equals -5. I know that that's just a horizontal line through -5. Slope of 0, b value of 5. Gonna graph the whole thing. Then we've got 4 minus x squared. Well, this exponent tells me it's going to be a quadratic. Isn't this the same thing as just -x squared plus 4? Yes, it is. So, how I do that, it looks like a quadratic. It's going to have a vertex of, well, there's nothing in parentheses, so it's just going to be 0. K is 4, so that is 0, 4. Let's use blue. There we go. And then I've got to make a T-chart. 0, 4 is the middle number, 2 numbers to the left, 2 numbers to the right. Plug them into that equation. So I'm going to do negative, parenthesis, -2, close parenthesis squared, plus 4. Gives me 0. Now I'm going to go back and put in -1. Gives me 3. Now a positive 1 is going to give me 3, and a positive 2 is also going to give me 0. So -2, 0, -1, 3, 1, 3, 2, 0. We'll lot the whole thing. The last piece, this is just a line, right? Slope of 1, or 1 over 1, b value of 1. So plot the b value, use the slope to make more points. I can go ahead and graph the whole thing, but now I need to go through and see where each of these is defined, and I need to erase the parts that I don't need. Okay, so my first line, y equals -5, I know that that's only defined when x is less than -3. So if I go on my x-axis to -3, which is right here, okay, so everything to the left of that I can keep, but everything to the right I've got to get rid of. Okay, and is it going to be an open or closed dot? We see it's open. Next part is defined between -3 and 2, so I need to erase everything to the left of -3, which is going to be everything down here, and then everything to the right of 2, which is going to be everything down here. And these are both going to be open dots also. So open dot again, so we have 2 open dots right there on the same point, and then an open dot here. Right, okay. And then x is greater than or equal to 2. So that's a closed dot with everything to the right of where this line hits 2. So then I just need to get rid of everything else. Just like that. Be careful not to erase the wrong parts. Okay, so now my domain of this, from left to right, it looks like everything is covered except for there's 2 open dots here at -3. So that tells me that -3 is not defined. So this is actually just going to be -infinity to -3 combined with -3 to infinity. Because I've got to tell that there's an open dot there. If one of those was closed, I would be fine. It would be -infinity to infinity, but they're both open. Okay, and then range, it looks like I'm obviously starting at -5. And looks like I'm defined everywhere else, because this is going up, 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 and then everything from this point up is defined. So I'm going to go -5 to infinity. All right, next one, 3 pieces. This first piece is an absolute value. Okay, the vertex would be -4, 3. So I'll plot that. And then if I look here, the slope is just going to be 1. So it's going up like this. Okay, it's only defined, I'm going to go ahead and erase what I don't need. It's only defined from -3 and less, so I don't need any of this, and I need to make sure that that's going to be an open circle there. Okay, next up, y equals 2x. That just means it has an intercept of 0 and a slope of 2. Let's look where this one's defined. It's between -3 and +3, so this is actually the last dot that I need to make on this line. And it's just going to look like that, so I don't have to go through and erase everything. I just went ahead and looked at where it was defined, okay? So it's just a line that looks like that. Make it look a little prettier. Closed dots on each end. We see that because of those signs. And then we've got a quadratic, okay? And that's this last piece here. Vertex is going to be 3, -2. We can do that. Let's do a T-chart. Okay. I need numbers that are greater than 3. So I'm just going to go ahead and plug in 4 and 5, and that's going to be it. I don't need to plug in 2 and 1. I can. I just know I'm going to have to go back and erase it, okay? So when I plug in 4 to that, again, using a calculator, negative parenthesis 4 minus 3, close parenthesis squared, minus 2 gives me -3. And then go back and put in 5, gives me -6. So now I've got 3 points here, and I've already told where this is defined, right? Because I only plugged in points I needed. So, therefore, I can just go ahead and make this the bottom half of my U, okay? And one more thing though, it's greater than 3, not greater than or equal to 3, so I'm just going to make that point open. And then I'm done. Well, that's right, domain. Left to right, looks like we do have a gap here on -3, but it's defined down here, so we're good. Same thing on +3, got a gap, but it's actually defined. So -infinity to infinity is going to be that domain. And then for range, well, starting from the bottom, everything, I've got stuff through here, and I've got above that. I don't have any gaps that aren't covered on range, so also going to be -infinity to infinity. 43. What is that? It is a quadratic with a vertex of 0, -3, because again, nothing's in parentheses with that x, so therefore 0 is going to be the h. Okay, T-chart time. 0, -3. Well, we could just go ahead and look. X is less than 0 is where this one's defined. So I technically don't need to do any numbers that are bigger than 0 because I'm just going to have to erase them. So I'm just going to do -1 and -2. If you did do the bigger numbers and then you went back and erased, that was fine. You should get the same answer as me. I'm going to plug this into my calculator. So negative parenthesis -2 squared minus 3 gives me -7. And then I'm going to go back and put -1 in. Gives me -4. Okay. So now I have these points. So I'm going to plot my vertex. Okay. And then I'm going to plot my points here. And make it a U shape going down. Open or close dot there. Well, it looks like that should be open. So let's do that. Okay. Next up, I've got absolute value bars on that, right? So that's going to be an absolute value. Vertex on that one's going to be 0, 4. Okay. So still on that y-axis. And then my slope on that is going to be 1. If I wanted to make a t-chart, I could, but I could just know that my slope is going to be 1 or 1 over 1, which is just going to be a V word or a V going upwards, and then reflect it going up to the left. Okay, but that was x is greater than or equal to 0, so technically I didn't need the left part. Okay. So this is what my function looks like. I can leave that as a closed dot on the absolute value portion. Domain for this, so from left to right, I've got a gap at -3 right here, but it's closed up here, so I'm good. -infinity to infinity for domain. And then range, whoa, on my y-axis I've got a pretty large gap right here. Y'all see that? Nothing is covering, there's no part of my graph that's covering that piece. So I've got to define that. So my quadratic, the range of that is going to be -infinity to -3, right? And that's an open dot, so I'm going to leave it as an open parenthesis, unioned with my absolute value, and that's starting at 4 and ending at infinity, which I guess I can leave that as a closed bracket because it equals 4 with a closed dot. Okay, 44 through 45. Write the piecewise function to represent the scenario and answer the questions. Okay, so this one is where you had to draw a graph, okay? So let's read through this little situation before we proceed here. So, your favorite pizza restaurant is having a sale. If you order fewer than 6 pizzas, they cost $10 each. If you order fewer than 6 pizzas, they cost $10 each. I would underline that. That's important. If you order between 6 and 10 pizzas, they cost $60. And if you order more than 10 pizzas, so more than 10, they cost $60 and $5 more for each additional pizza. So write the piecewise function. Okay, so let's break this one down and see what we got going on here. So, fewer than 6 pizzas. So we'll just go ahead and define our variable. So our variable is going to be, let's just use x, okay? And x is going to equal pizza, or amount of pizzas. So 1x would be 1 pizza. You with me? Okay. So how I would solve this is if x is fewer than 6, okay, so if x is less than 6, that looks like part of a piecewise function, right? Okay, so let's go ahead and just start putting this, let's write the bones of the piecewise function. Maybe that would be a good starting point. So we know it's going to have a y equals, or f of x equals, and then we know we're going to have this parenthesis. We know we're going to have our equations here on the left, and then this right part is going to be where x is defined. So if I order less than 6 pizzas, okay, x is less than 6 is going to be what I put on that right-hand side. If you want to get technical with it, can you order a negative pizza? Not really. So really this could be 0. X is between 0 and 6. Okay, because we know we can't order a negative amount of pizzas. But if you didn't catch that, if you just put X is less than 6, that's good, because I'm going to know what you mean by that. Okay. So that's the first piece. When X is between 0 and 6. Okay. What do the pizzas cost, though? They cost $10 each. Okay. Do we know how many we got? I mean, we know we got between 0 and 6, but we don't know exactly how many. So we'll go ahead and put 10, but put 10x, 10 times the amount of pizzas we got, because obviously that's going to change. Okay? And then we've got when x is between 6 and 10. So we said the first one was fewer than 6, and now we're saying between 6 and 10. So technically, this is including 6 and 10. Okay, so if you ordered 6 or you ordered 10, it's going to be included in this piece. So that's why I'm going to use less than or equal to signs and greater than or equal to. I'm not going to use just less than and greater than. Okay, they cost $60 total. Okay, well, I'm definitely going to be ordering 10 then, right? It's going to cost $60 no matter what. So it's just 60. I'm not multiplying that by anything. It's just $60. Okay? And then the last one says, if it's more than 10, so greater than 10, and again, there's no cap on that, so just greater than 10, however many, they could order 1,000 if they wanted to. So if you order more than 10, and they cost $60 and $5 more for each additional pizza. So $5 times the additional amount of pizza. So this one is a little bit difficult. I don't really love this question. For each additional, we're actually going to use x minus 10, okay? So $5 times x minus the 10. So for instance, if I ordered 10, that's no additional, right? So if I put in 10 for x, 10 minus 10 would be 0, so I'm not being charged anything extra, okay? But if I were to order 11 pizzas, so 11 minus 10 would be 1, so I would be charged $5 times 1, which is just $5. Does that make sense? Hopefully. So it's a little bit trickier on thinking how I would set that one up, but it does make sense logically when you put it together in your head. Okay, so now I just need to graph this. We'll go ahead and, since it's not we're not doing anything negative because we don't have any negative amounts of pizzas or negative amount of money, I'm just going to go ahead and just make this the first quadrant of my graph, okay? And if I wanted to label it, we know that we said x was pizza, or amount of pizzas, so number of pizzas, and then the y-axis is obviously going to be amount of money that we're spending or cost. Okay, so pizzas, it looks like really I at least need 0 to 6, 6 to 10, and greater than 10. So I'm just going to go up by ones, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is right there, okay? So we'll put a couple numbers on here. 1, 3, 5, 7, 9. Okay, that's kind of sloppy, but you get the gist. And then my y-axis, I know I'm at least going to be having 60 on there, probably more, so we could just go up by 5, so 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 60, 70, 80, and I'm going to stop there. Okay, so the first one is y equals 10x when x is between 0 and 6. Okay, so 10x, gonna have 0 is going to just be that intercept, right? And then my slope is going to be 10, so up 10 over 1. Here, let's do a different color. So my intercept here, up 10 over 1, up 10 over 1, up 10 over 1. And again, I'm watching my intervals here. And I'm going all the way to did not label that very pretty. Right there, okay? So this is my graph. And this is gonna be an open dot on 6. Okay? And then we got y equals 60 when 6 is between 6 and 10. And we know those are gonna be closed dots. So technically it looks like I'm already there. So we'll just go ahead and do that. And then this was 10 right here. Okay, and then my last little bit there, when x is greater than 10. Well, let's simplify this real quick. So 60 plus 5x minus 50, just gonna be 5x plus 10, okay? So my interval there would be 10. I know I'm gonna end up erasing that, but I would go up 5 over 1, up 5 over 1. So my slope is gonna end up being like a 1 over 1. Okay, and it's only when x is greater than 10. So that would be an open dot, but there's a closed dot behind it, so that one's kind of tricky to draw, but just make sure I can somewhat see both. And then I'll erase everything to the left here. Okay, so that is what my piecewise function, although I'm not the best artist, that is what it would look like. How much would it cost to order 8 pizzas and then 15? Well, that one's pretty easy. We're just putting in f of 8 and f of 15. So when I plug in 8, I'm using the middle one. Well, I don't even have to plug anything in. I just know that's going to be 60, okay? So f of 8 is going to be $60, okay? And then 15 pizzas, I'm going to plug into the bottom one, which I already simplified. So f of 15 is just going to be 5 times 15 plus 10, which is $85. And I graphed it already. Okay. Your cell phone plan has new bundles for data. If you use up to 3 gigabytes of data a month, you will pay $15. You will pay an additional $5 per gigabyte of data beyond the 3 gigabytes. Okay, so write the piecewise function. So f of x or y is what we can put here on the left. We'll just do f of x equals 3 gigabytes of data a month, you'll pay $15, so up to 3 gigabytes. So is that 3 or less or 3 or more? If it's up to, it's going to be less than 3, right? Or including 3. So if x is less than or equal to 3, can we use a negative amount of storage? Technically not, so we'll put a 0 there. And it says we'll pay $15, so just 15. And then it says you will pay an additional $5 per gigabyte of data beyond 3 gigabytes. So this one's also one you got to think about. So if I used up to 3, I had to pay this $15. This $5 just says additional, so I'm still paying the 15 plus $5 times what? Well, kind of like the other one, additional just means more than 3, right? So I need to subtract that 3 out of there, and then that's what I'm multiplying by 5, because that's going to tell me how many additional minutes that I use. And this is when x is greater than 3. If it's equal to 3, it's going to be 15, because again it said up to 3. Okay, but if it's like 3.1 or 3.2 or anything bigger, it's going to be greater than 3. How much would it cost to use 14 gigabytes? And then how about 2? Well, 14 means I'm going to plug it into the bottom one, right? We'll go back. We'll do that after we graph it. So I'm going to graph first. I think that's easier. So my x's, I know I need to go from 0 to 3 and greater than 3. So I'm going to do, I guess, just 1, 2, 3, 4, 5, 6. And this is gigabytes. And then my y is going to be money, so cost. Don't have a lot of room here. For y, I know I've got to have at least 15 and then a little bit more, so I might just go up by like 5. So 5, 10, 15, 20, 25, leave it at that. So we'll go ahead and graph this. So 15 is what it costs if it's between 0 and 3. So let's zoom in here so we can kind of see this. So 15 is what it costs when it's between 0 and 3. Open dot on 0, close dot on 3. Just like that. And then we can simplify 15 plus 5 times x minus 3. And it's going to give us 15 plus 5x minus 15. Well, if those cancel out, I just have y equals 5x. Okay? So if that's the case, 0 is my intercept. Up 5 over 1, up 5 over 1, up 5 over 1, up 5 over 1, up 5 over 1. And I know that this is just when, I should use a different color. I know that this is just when x is greater than 3. So open dot, x is greater than 3. So I don't need all of this below. Okay? So that is how I draw a piecewise function. When I've got 14 gigabytes of data, I need to do f of 14. Plug in 14 to the bottom part. I can actually just plug it into the part I simplified to, but either way I'm going to get the same answer. 5 times 14 is 70. $70. Okay, and then if I plug in 5, I know that's just going to be $15. Not multiplying it by anything. Okay, that is it on this review guide. So make sure that you are ready for the test. If you have questions, make sure you come see me. Okay? Other than that, that's all I got for you guys. Thank you very much and good luck.